we can go to the data lake transformation pipelines that we are covering for this week. We can go through what all are the possible questions can come in the actual pipelines that you have worked on. Okay, so as we know that the data lake, we are not designing the data lake house at the moment. Okay, we need to be very clear. Probably you know the difference between data lake and data lake house. We are not yet start using delta table here. In the Databricks landing we will start to use the delta table, because without the Databricks you can't able to design the delta table. The ADF alone can't able to create the delta table without the Databricks, because it is involving the set of Python libraries and some coding that ADF can't able to support at the moment. Okay, that is the one of the best business case for when to use the ADF and when to use the Databricks. If we need to design the data lake house using the delta tables, then we definitely need the Databricks. Okay, so we all know that Databricks has got the bronze layer and the silver layer and the gold layer. Bronze layer is exactly similar to the data ingestion pipelines that we have developed for our reporting database. Only it's called as bronze layer. When we building the reporting database, we called it as the landing layer. In our specific course, I specifically introduced the REST API. Our source data is existing in one of the API. You need to make the request to the REST API using the ADF. All the REST API, probably all the REST API may be a very strong word. Most of the API send the response in the JSON format. Okay, the request and response, all of them I am talking about, it's in the air actually. In fact, it's not stored at all. We are sending a request to the software, and that software is responding the response in the JSON file, and we have designed to store that in the ADLS Gen 2 account. If you have done the bronze layer ingestion pipeline, you know how to store the response JSON file in our ADLS JSON file. And again, we have developed the metadata driven pipelines here. This is the good exercise for repeating your previous metadata driven pipeline. So far, I think we have developed only one time for ingesting the source pricing data. Here you will be getting 2 time opportunities to repeat that one. And the bronze layer ingestion is exactly similar to the ingestion on the original pricing data. Only the source type is different here. That's all I can say. Again, silver layer pipeline design, what we are doing it here is that our original data is existing in this format. Okay, we are bringing 2 additional data on top of this pricing information. Our main objective on designing the data lake is supporting the price prediction algorithms for predicting the prices of these products in the future. So those factors affect the prices of this product is, we are mainly taking the market name and what is the population in that market name and what is the weather condition in that market name. This information is existing in this REST API, and we are bringing the data. That data has got some complexities. If you do the hands-on, you know how to resolve those complexities while populating the silver layer. Specifically in silver layer, what we are doing is that we have got the complex JSON data from these REST APIs. We are making that one flattened in such a way that the data can be directly joined to this pricing data using this market name. We are mainly capturing the population data and weather data at individual market level, and we are merging the data into this pricing information that can be fed into the price prediction algorithms, because price prediction algorithms need what factors influence the price. For us, actually, we have come out with something logically affect the prices. We didn't go in depth about exactly the other retail indicators or something like that. I would like to bring the data that makes sense to everyone, why we are bringing the additional data. So what type of transformations have done in the silver layer? This is where I am talking about consolidation of the bronze layer data to consolidation of the bronze layer data to bring it into common format. Okay, it can be something like flattening the JSON nested arrays, or it can be converting all prices into common currency, and even we are capturing the data in different time zones, we can come into the converting all data into common time zone. It can be the UTC. These type of the things normally we do in the silver layer. In our specific example, we are making sure that the additional data that we are bringing for joining to the pricing information will be in the same format as the pricing information is captured. Okay, and specifically in designing the data flow, you have started to use the source wildcard path, because previous pipeline design we just pointing to the specific source file name, but here when we are ingesting the pricing data, there will be multiple files will be coming from the source, not in the bronze layer. I think silver layer we have done that one. For example, if I go to the silver geolocation data, we have defined the data flow. In most of the cases, we are pointing our source data into one of the specific file, but if multiple files with the same format will appear, how you will read those files using this the additional source option is called the wildcard path. That is the one thing we are exploring on top of what we have learned in the data factory. On top of that, there is a new transformation is called flattening, because our source data is in the complex data type. For example, all of the source data that we are loading the reporting dimension tables, either it will be string or integers. If you inspect the columns, it's not the complex data structure. But if you come to the new data that we are bringing in from the source silver geolocation data, it is complex data set. Okay, this is the array. Inside the array, this many columns are there. We need to bring this complex data into the plain flattening format. So there is a new transformation called flattening, and how to configure them. If you look at the output of that one, it will look like our original source data. So that is the one of the main transformations we focused about it, because that is the very standard question for converting complex data type into the standard data type, or they call it as flattening the nested complex structure. Here I think we have got only one level of nested structure. When populating the weather data, I think we have got multiple nested structures. Okay, so how to convert these multiple nested structures into the plain format? Basically, you need to use the multiple flattening levels. That's it actually. It's very simple if you gone through the videos, and most of them have done it actually. The guys who have done the course up to 85% can see this code actually. So you have done it. So the how to use the wildcard path on the source files, it is possible at copy data activity as well. Okay, I have explained only at the source data set level. It is possible at the normal copy data activity as well. You can able to define the wildcard path for your source files. Okay, so I just try to bring it into that wildcard requirement to your attention, because there might be questions possible saying that multiple same type of files are available, then multiple same type of files exist in source folder, and how to read all of the files. So use the wildcard path option on the source. And data flow parameter usage, we already used the data flow parameter in the loading the redesigning the dimension table loads. Here also we have used actually, and how to use that in the wildcard folder name as well. We have done it in developing these pipelines. I try to cover as much as possible real-time information here. I think we have used this wildcard folder name here, and we have used that in the wildcard path along with the folder name path and the star.json. Okay, how to use that one, that is also we have explored. I think when you complete the end-to-end hands-on, guys, you yourself start to feel very good about it, because the scenarios are if you really understood what is the output, and that is the main purpose of this live session as well. I try to give as much as context here, Okay, and so far we created metadata file manually only. Okay, but here we created the metadata file itself dynamically using the data factory. We used the ADF data flow to create the dynamic metadata file. So that means very low coding. We are developing the code in such a way that there won't be any further user intervention required at all. It automatically take care everything using the ADF data flow to create the metadata file. These type of requirements will come when metadata is too huge. Okay, I think in our case it is going up to 6,000 records. Actually, we need to create the metadata file. Manual creation is too time taking and erroneous as well. We quickly possible to create some erroneous records easily. So automated way of creating, it's not required all the time, but we explored, we extended our ADF knowledge to some extent, and we handled one layer of nested JSON file and also multi-layer of JSON nested files. We used to flatten transformations. Okay, that's not much difference. Multi-layer, you need to use the multiple flatten transformations. When we use the same thing in the Databricks, it will be little simpler. Even though it's coding, it is more simpler than ADF in that aspect as well. So that's all we discussed in the course up to silver layer. There will be only 2 more sections for the next week. So we can extending whatever we are learning at the moment. Not much learning here, to be honest. Actually, the gold layer is merging the silver layer data with our original pricing data that is coming from the HTTP web server. So these 2 layers, very quick one. Next week probably we'll discuss about the CV preparation, because with respect to ADF, if you come to this level, I don't think you don't need to learn anything more. Actually, very confidently I can tell you, and you can able to handle that, because this is what we are going to update in the CV as well. Ingesting the data from the web server, ingesting the data from the source system, ingesting the data from REST API. And all of them we created as a metadata driven pipeline. If you did the hands-on, you know how to do the metadata driven pipeline. Then we designed the dimensional data modeling for dimensional data modeling for reporting database, and data lake for AI and ML requirements. And in dimensional data modeling, the dimension table and fact table, nothing else we can populate it, nothing else they can ask about it as well. Actually, in data lake, with specific to a context, we need to say what data we populated in bronze layer and what data we populated in silver layer and what data we populated in the gold layer.